Okay, guys, so in next session, we will discuss the project. As in previous session, we have completed an introduction. Today, we will learn some basic concept in cyber security related to basically networking. Okay, so before starting the concept, I will again start with very basic question. What do you mean by network? Yes, anyone can unmute and give answer. What do you mean by network?
So can you repeat the question?
Uh, what do you understand by network? Like
When
what is
network?
network? Simple. No, simple network. No any LAN, WAN,
Simple.
MAN.
Okay.
For communicating between two devices.
Sir,
Yes.
it's kind of like a system which helps to communicate between multiple devices and help us share information as well as resources.
Hmm. Connection of
Arrangement of
devices for
devices.
communication. Okay, arrangement of devices.
Two or
Okay.
more computers are electronic devices, so it's interconnected for the purpose of exchanging data and sharing the resources. So, for the basis, so we can use network. Mainly, we can interconnected or interrelated for the chain or group systems.
Okay. So basically, like all of you are correct. We have a conclusion statement. Network is nothing but a connection between two or more computers or devices. And it may be any device. It may be your computers, laptop, mobile, IoT devices, your smartwatches, anything. If we are communicating, we are doing device to device communication. Okay, between two or more than two devices, then it is a network. Now, if we will go in deep, then we have concept of LAN, WAN, MAN, all the topologies and all. But whenever we are starting the cyber security and whenever we are into cyber security, so we are always focusing on network. Okay, that we need to understand the network. Computer networking itself is a subject or a wide subject of cyber security. So why we are focusing on networking when we are talking about cyber security? Yes, question is why we are focusing on networking when we are talking about cybersecurity.
All the basics are included in that.
Yes,
Mainly,
Basic,
basis of the
So may
protection of
I?
the
yeah, sure.
So network security basically a subset of cyber security. So that is why we need to know what is network and the security.
You are saying subset of cybersecurity, but I believe that this is the base of cybersecurity. Now let's understand. Okay, uh, either we are on web security or app security, or we are working on server side or client side, anything. End of the day, all the data will be communicated through a network. Okay, all the resources will be shared through a network. And in network, we have we should provide security. And in network, you can say that this is an open field for any kind of attack. Okay, so that's why we are learning network security and concept of networking before getting into cyber security. In today's session, also we will learn these things, the fundamental of network security. Okay, so that I hope that all of you have an idea of all these things. But before getting into the main project, so it will be a recap for you so that you can brush up your brain and work. So in networking, we have the main concept or the base concept, the OSI model and TCP/IP protocol suite. Okay. So the concept of OSI model is very simple. We have multiple vendors of electronics devices which are supporting the network communication. Now, if every vendor will use their own technology, okay, or their own creation, then the communication between cross-vendor machine, that will be very difficult. So to solve that issue, International Standard Organization ISO have created this OSI model, okay, in 1984, so that everyone will get the idea how we need to process the data when it is in, you can say that, when it is in communication. Okay. So it is basically created in 1984. And what is TCP/IP? So basically, OSI is a reference model. Okay, it is not a implemented model. As ISO is a standard organization, not an engineering organization. That's why it set the standard. Okay, if you want to process the data, so you need to follow up these steps. Now you are free to use any technology to follow up. That ISO have said that you need to do the encryption. Now it is up to you what algorithm you want. Okay, the concept is similar. So in OSI layer, OSI model, we have 7 layers. Can anyone explain what are those 7 layers?
Application layer, physical layer, data link layer, um, presentation layer, so,
Okay. So
Layer and
whenever you
transport layer.
whenever you are explaining the OSI model, okay, it is a favorite question in interview also. So try to explain in serial. Okay, like you need to start from the application and then presentation session like this. Yeah. So you need to start from application, presentation, session, transport, network, data link, physical. So what concept we have here? Whenever we are transmitting the data, so in this slide we have the example, like we have one Windows operating system and one Mac operating system. They have different network interface card. So if we process the communication through the card only without any model, so maybe Apple will follow some different rules. Okay, so that's why we have OSI model. Now when Windows machine is sending the data, so we can see that on sender side it start from application to physical, and on the receiver side it start from physical to application. Okay, then we have basic network architecture. Okay, so as you can see that these 4 from application to transport. Okay, so these are peer-to-peer communication, and after that, like network, data link, and physical, these are communication subnet boundary. Okay, basically, what happens whenever suppose your data packet is, all of you know what is data packet or datagram? Okay, all of you know what is data packet or datagram?
Yes, sir.
Okay. So whenever your like data is in application layer, it will go for peer-to-peer communication, like from application to application. And with this image, you can understand these things very easily. Okay. After that, we have the second important thing, the TCP/IP model. Now, this is the implementable model. Okay, widely we are seeing this, the TCP/IP. Why the name is TCP/IP? Because in this implemented model, we are mainly using two protocol: transmission control protocol and internet protocol. Okay. So in TCP/IP we have 4 layer only. So first three, from application to session, we know as application layer in TCP/IP. Then transport layer is as it is, and network layer is as it is. Then data link and physical will be network access layer. So here we have a basic overview of all the layers. Okay, like application layer. So it is going to provide you a set of interfaces for application. Okay. Then we have presentation layer. It basically work for data translation, encryption, decryption, and mainly data format conversion. Okay. For example, suppose you are sharing a image. In network, it is in binary, right? So, well, when it comes to your machine, on each layer that will be processed. So in presentation layer is going to decide whether this is an image or MP3 or any kind of video, anything. Okay. Also, when you are using website, so it will show you whether it is a hyperlink or simple text, anything. Okay. So also for achieving the goals, like whatever the responsibility we have on presentation there, for achieving this, we are using protocols. Can anyone explain what is protocol? Yes, anyone. This is a common word, right? Protocol. Yeah, set of rules. Yeah. So we use a set of rules, that is protocol, for achieving our goal on specific layer. So on presentation layer, we using APL, LPP, or NDR, then SSL. Okay. After that, session layer. So the session layer is responsible for mainly session establishment, then dialog control, synchronization, checkpointing, and termination of session, or you can say overall session management. Okay. So what is session establishment? Whenever we are communicating to server, so we need to create a specific session for that. Okay, that session is for a limited time period. Then we have dialog control and synchronization. In synchronization, we are basically we are syncing our device with the we are syncing our specific tab or device with the server so that we can get real-time data or we can get accurate data. Then checkpoint. In between the communication, we are ensuring of like ensuring for integrity of communication. Okay. Then whenever our requirement is over, we are terminating the session. If we will not terminate, then it may be misused by some unethical people. Okay. For this, we are using NetBIOS, NFS, PAP, SCP, and SQL zip and all. After that, we have transport layer. In transport layer, we basically do segmentation and reassembly, end-to-end communication. In transport layer only, we are adding port address. Okay. So, do you know what is port address?
To provide the reliable delivery of data transmission.
Yeah. So that basically, yeah, that is correct. But listen, in port address, what is this? This is a logical place in a system, okay, where we establish our communication for a specific protocol. Okay, suppose you have HTTP. For that, we have a specific port, is a port 80. So in this layer, we are using mainly two protocols, the TCP and UDP. And this is the core of the communication also. TCP, basically it is transmission control protocol, and UDP is user datagram protocol. Specific these two protocol I will explain in the next slide. Okay. Then we have network layer. Here we are adding logical address. Now what is logical address? Logical address nothing but the IP address of the machines. Okay. Then we are ensuring the routing where it is going to be a static or dynamic routing. Then we are also going for packet forwarding, okay, packet switching, and QoS, quality of service. A few things you will find that are common in multiple layer, that error handling, okay, or session, yes, error handling. So it happens on multiple layer for you can say that for the proper communication. Here we are using protocols like IP, ICMP, IGMP, and RIP. These things we are using here. After that, we have data link layer. Here we are adding physical address. Physical address is nothing but the MAC address of your device. Then we are doing the framing, access control, error detection and correction, and flow control. Here we are using protocols like ARP, ATM, frame relay, PPP, etc. Okay. Then in physical layer, basically it is nothing but all the physical component. It may be a wired or wireless. Okay. So that we manage in physical layer. Here we are using protocols like Bluetooth, Ethernet, DSL, Wi-Fi, and all. Okay. Now TCP and UDP, we need to understand these protocols briefly. TCP is basically transmission control protocol. Okay. And this is a connection oriented protocol. It means that it will check whether the complete data is transmitted or not. Okay, whenever you are transmitting data through TCP protocol, so it will take a acknowledgement of the delivery. Where UDP is a connectionless protocol. Okay, in UDP, the sender just send the data. It don't have any business for checking whether it went successfully or not. Where TCP is slow but reliable, UDP is fast but not reliable. Okay, we have some key difference here, like connection type. So TCP is connection oriented, UDP is connectionless. Then TCP is provide a reliable data delivery. UDP don't take any kind of guarantee for delivery. It will just do the best effort. Okay, and TCP is slow, UDP is fast. Okay, so in use cases, we can see that the web browsing, email, file transfer, these all are happens in TCP, and in UDP like live streaming, gaming, voice over IP, okay, DNS and video calls. For this, we are using UDP. Now in live streaming and video calls, usually you can observe that if you have slow connection, then it is stuck, not pause. Okay, but in YouTube video, if you will you have a less bandwidth, so it will buffer and start from the point where it started buffering. But in live video, you can see that it is going to be the real time data. Okay, then in data delivery, it is oriented and error checked. In UDP, unoriented and error prone, and the overhead is high, like adds header for reliability, but in UDP it have a minimum header size. Now, as we understood the TCP and UDP, okay, guys, any doubt in TCP and UDP?
No, sir.
No, sir.
No, sir.
So let's move to
No, sir.
okay.
So IP address are the backbone of internet. Okay, IP address are like your logical address. In simple word, if I need to explain IP and MAC address, so MAC is your permanent address and IP is your temporary address. Okay, now we usually don't change our permanent address. Okay, it is in all documents and all. And the temporary address we usually change according to our location. The same concept is there. The MAC address is attached with your hardware. Okay, suppose we are using laptop, so it have a specific MAC address and that is fixed. However, we can go for MAC spoofing also, but in general scenario, this is fixed. In IP address, if you are using some mobile internet, then your ISP internet service provider will provide the IP, or you are in Wi-Fi or in local network, so they will give you IP. Okay, so let's understand what is IP address. So it's basically a unique numerical label, okay, assigned to each device, okay, connected to the network. So we have two type of IP, IPv4, IPv6. IPv4 is a 32-bit address, whereas IPv6 is a 128-bit address. Now, I hope that all of you have a basic idea of IPv4, IPv6 and all. A simple question is there, when we have IPv4, why we introduced IPv6? What is the requirement? Why we need requirement of IPv6?
Because the IPv4 is very limited for the global level.
Yes. So when the internet started, we introduced IPv4, IP version 4. In that we have 4.3 billion unique combination. Okay, we have a possible combination of 4.3 billion. But however, we have multiple devices, okay, that are connected to internet with real time. Okay, so in that case, we are going for a lack of IP address. So we introduce IPv6, which have more than 18 trillions. Okay, I think it is written somewhere. Okay, let it be. So, okay, so it is it have IP possible combination in trillions. Okay, so basically IPv4 we have in numerical form, whereas IPv6 we have in hexadecimal form. Okay, so if we will see about see the structure of IP, so we have two portions, the network and the host. Okay, and also we have some categories in IP address, basically in IPv4 address. So we have the first category, that is public IP address, then the second, which is private IP address. Now, public IP address, for example, you are connected with your Geo SIM. Okay, so in that case, the Geo will provide you a public IP address, which is accessible over the internet. Okay, but the concept of private IP address is, suppose you give the hotspot to someone, so that person will assign a private IP address from your device. So whenever he will do any kind of web surfing, so on internet, your device, or you consider the parent device IP, will be shown. In industry point of view, we are using LAN, local area network, in our organization. So we have a concept of default gateway. So we have one public IP address. Okay, that is our default gateway, and we are providing private IP address in our internal network. So for communicating, whenever you are using the outside net or the World Wide Web, so your query will be follow the default gateway, and on internet your query have the default gateway IP only. And when the response will come, it will come to a default gateway. After that, it will circulate it to you. Okay, and we are assigning IP address in two methods: dynamic and static. Okay, so dynamic is temporarily and static is permanent. Now, why we need? Suppose you are in a organization. Usually, you connect disconnect Wi-Fi. So you every time you will assign with a temporarily IP address. Okay, but when it comes to your default gateway only, so you have configured everything according to your default gateway. If the address will be changed rapidly, so you need to do the configuration again. So in that case, we are using static IP address. Okay. Then we have a comparison table. Let's see. IPv4 is 32-bit long address, where IPv6 128. So if we want to calculate, we have a equation like 2 to the power 32 or 2 to the power 128. By this calculation, we can calculate. Then in IPv4, we have two options: manual and dynamic. Okay. In IPv6, we have auto IP configuration. Then in IPv4, we have a variable header of 20 to 60 byte. In IPv6, we have a 40 bytes fixed header. In IPv4, no end-to-end integrity is there. In IPv6, we have end-to-end connection integrity. In IPv4, we don't have any security mechanism. IPv6 comes with IP security. Okay, IPsec. IPv4 use checksums, whereas IPv6 don't use any checksums. Okay. IPv4 use IP classes and VLSM, whereas IPv6 don't have any class and don't use VLSM. In IPv4, no packet identification. In IPv6, we have that like quality of service. And in IPv4, the last one, fragmentation by the sender and the forwarder. And in IPv6, fragmentation by only sender. So these are a few differences between IPv4 and IPv6. Okay. Now let's understand the structure, which is the important part in IPFJ. Okay, any doubt till now?
No, sir.
Okay. So as I have said, in IPv4, we have some network portion and the host portion. Okay. So basically, it is divided into 4 parts, and every part is of 8 bit or 1 byte, you can say. Okay. So the network portion identifies the network to which the device belongs. Okay. And the host portion will identify the specific device within that network. Now let's see how it is divided in different classes. And according to the division of network and host portion, we have classes. So we have classes like A, B, C, D, E. Okay, so in A, you can see here the N represented network and the H represented host. So how we are going to identify whether this IP belongs to which class? So for IP whose belongs to A class, we start from the first octal. Okay, the first one will start from 1 to 126. Okay, whenever you are connected on a private network or Wi-Fi, you will find that you have a IP like 10 dot or 16 dot something something something. So that is a class of IP. In that we have number of network is 126. Okay, and the maximum number of nodes is 16,777,214. Then we have B class IP. It started from 128 to 190. Actually, it is 127 here. Okay, no issue. 128 to 191. And here we have also a concept of subnet mask. So I will explain that later.
Sir,
In
I
this
have
we
one
have two.
question.
Yes.
Sir, we will use a 127 for troubleshooting, not for IP
Yeah, yeah.
class 1.
Yeah, that is loopback IP 127.0. Oh, yeah, of 127. That will be your going to be your loopback IP. Okay,
Yes, sir.
that's why this is not written. Yeah, that's why I left that. Okay, so 128 to 191. That is having two octal for network and two octal for host. So you will find 16,384 for network and 65,534 for host or nodes. Then we have C type IP. Okay. So it basically starts from 192 and end on 223. It has three octal reserved for network and one for host. Okay. And the D and E, these all are reserved. Okay. E is for broadcast and D is for research purpose. They start from 224 to 239 and is starting from 240 and end on 254. This is the classification of all the IP. Okay. Then we have the details of these things. So I think no need to explain this. Okay. Basically, we have range here, like start from 1000 and on 127, 255, 255. Accordingly, we have range in every IP. Okay. Any doubt in IP address?
No, sir.
No, sir.
Now we need to understand the DNS. Okay. After the IP address, as of now, we understood the OSI layer, then the TCP IP protocol suite. So we understood that how we will communicate from one device to another device. But on internet, we have different domains, and it is not like that we are directly communicating. We are communicating through a mechanism. Okay, and DNS is a part of that mechanism. DNS stands for domain name system. Okay. Now, what is DNS? Can anyone explain?
Sir, may I?
Yeah, sure.
Sir, DNS is a basically domain name system.
Mm,
It is
mm,
providing a IP domain name, which is domain name, and it will convert in a IP.
mm. Okay. So, look, suppose you are using google.com or Facebook. So you can remember the name of Google. But on internet, we have seen that the communication is happening through the IP address, right? Now, whenever you want to communicate with Google, so you are not entering the Google IP address into your project. If you enter that, definitely you can access the Google, but usually we are not doing that. We are doing that. We are simply typing the google.com in our browser. So domain name system will convert that domain name into the IP address and IP address into domain name. It is a phone book of internet. Okay. So it basically translates. Yeah, it is hard to remember the IP address because as a human, the numbers are pretty much difficult for us to remember, whereas name we can remember. Also, Google can advertise themselves as a Google, but he cannot advertise as a 8.8.8.8, right? Now, the main purpose is it allows user to access the website using easy to remember domains name. Then it has some key point. The first thing is functionality. Functionality is simply translating the domain name into IP and IP to domain. Then it has some components like DNS record. Okay. Then like CVMs, then mail exchange. Okay. So also DNS is a big topic. In a single slide, it is difficult to difficult to understand, but on a simple manner, you just can remember it is nothing but the phone book of internet. Okay. So now we understood whenever we are communicating on internet, so we are typing something. So the that text is converted into the IP address. Then our request will forward to that IP address through our TCP/IP protocol suite, or you can say that SI model. Okay. Now when, we need to understand the DSCP because in static IP it's a manual configuration. Okay, so okay, the organization will give you a static IP. Now you have your on IP address. You are communicating through multiple vendors, so their domain name and domain name is converted into IP address by DNS. But when it comes to dynamic IP, we need to use DSCP. Okay, dynamic host configuration protocol. So it basically used to assign the IP address automatically. Okay, it basically reduce the workload of network administrative. Suppose if you don't have any DSCP service or servers in your organization, every time when a new device wanna enter into your system, you need to configure that device manually. Okay, so to reduce, and whenever you will exit, you need to remove them. To automate this process, we have DSCP. Now, how DSCP is going to provide you dynamic IP? So it uses DORA method. Okay. Now, yeah, here we have DORA method. And we have a concept of lease time. We will see in this slide. In DORA method, as you can see that we have discover, offer, request, and acknowledgement. So whenever you are in a local area network or a network where we have DSCP, the first thing, your client will broadcast a discover packet. Client means your machine. As your machine don't know the IP address or the location of your server, it is directly going to broadcast. Okay. So in broadcast, it will provide his current ID, or you can say that MAC address. Okay. So here we have discover packet. When a server will find a discover packet, it is going to give a offer packet. In offer packet, it is not going to assign the IP address. It's just offering that I can. Okay. If you want, you need to reply again. So on the reply of that offer packet, your client will send a request packet. Okay. He will do a request that yes, I need IP address to connect and for using internet. In response of that request package, the server will provide a acknowledgement packet with a dynamic IP for a limited time period. Okay. So it means that IP is on lease period. Lease, all of you know the concept of lease. We are getting something for a fixed time period. So that is lease. if the communication will go in within that time period, so after that time, automatically that IP will be back to DSCP server and will put it in the DSCP IP pool. Okay. And if a client wants to be in that network for more time, so before the lease period end, it will send one more packet to extend the lease. Okay. And every time when the every time you need to follow the same step. So by this method, as you can see that in LAN also or in DSCP also, we are getting our IP back after the communication or after the service end, so that we will not face a lack of IP address. Okay. Hence, we have lot of more component in DSCP also. We will see if that part is required for our project, so we will learn that also. Now for web communication, we have HTTP. Okay. Do you know what is hypertext?
Hypertext transfer protocol, which is used to data is
No, no.
travel
I
in
am
the
asking
URL
what
path.
is hypertext?
Yeah. HTTP, in HTTP, the
Leave
inserted data
HTTP.
that are
Just simply
traveling the
explain what.
URL.
What?
Travel in the that data content travel in the URL. They do not encrypted or not any advanced security in HTTP protocol.
Okay. So that is HTTP. Okay. That
May I
here.
know?
Yes, sure.
Yeah, hypertext means it contains only links and text and resources.
Okay. Any other wants to try? Okay, so basically hypertext is nothing, but it text that contains the hyperlinks. Okay, in simply word, you also see if we want to add a resource on a specific text, so we are using hyperlink there. So in hyperlink, we are just adding hyperlink or assigning hyperlink to simple text. So that is our hypertext. HTTP is nothing but the protocol to transferring that hypertext. Okay, it it is used for web communication. Okay, or the transferring the data over the web, enabling communication between web browser and server. Okay, it allows user to request resource. Okay, like web page, image, MP3, anything from web server. So as HTTP is not very secure, but this is the base version of the secured HTTPS. Okay, HTTPS is basically hypertext transfer protocol secured. So nowadays, although we are using HTTPS, but we need to learn the basics. Okay, so the functionality is like HTTP defines how messages are formatted and transmitted over the internet. Okay, so basically, it uses some method. So those who know the basic development, they will understand this method. The get, post, put, update, delete, all these methods used by HTTP. Okay. So through this method, we can communicate with the server. Suppose we want some information or some data from the server. So we will go for get method. Okay, as get will get will be a part of our hypertext only. Okay, so we will use that. So we have some website nowadays. Also, we have some website over HTTP. In HTTP, the main problem is the data is not encrypted. Okay, so when our data is in communication, we can directly see the data. when HTTPS, the data is encrypted. Okay, so this is the basic of HTTP. Then we have HTTPS. So basically, it is secured and it provides security with the SSL and TSL certificates. Okay, and basic and all the things are it also used for transferring the hypertext only, but in a secured manner. Now, as we learn of IP address and the use of IP address, so after IP address, we are always putting the port numbers and the ports. Okay, so ports are nothing but the virtual communication endpoint used by device and application to facilitate data transfer across a network. In networking, ports are associated with IP address and allow different type of network traffic to be directed to the appropriate application or service on a device. Let's understand with a simple example why port address is important. Okay, suppose you have a traffic of FTP. Okay, FTP over TLS or SSL. So it will use the protocol of TCP and the port number is 989 or 990. Now you can see that the TCP is used by Telnet also or SMTP also. So if we will not assign a proper port number, so the packet will be confused on which location I need to go. Okay, on which virtual communication endpoint I need to go. So if FTP traffic or FTP over TLS traffic will go to, for example, SMTP port. So SMTP port cannot handle or process that traffic. Okay, so that's why we have port numbers. Also, guys, try to remember all the basic or fixed port number because in interview or in competitive exams also that is a favorite question to check whether the candidate is having the basic or not. Then we have firewalls. What is firewall, guys? This is the very good topic. I hope that all of you know about this. What is firewall?
Sir, may I?
Yes, sure.
Sir, it is like a set of rules which we put on a network to uh, stop the traffic or like stop certain sites from ongoing and ingoing traffic.
Okay. So yeah, correct. Firewall basically work as a security guard. Okay, for your network. So it is basically a network security system. It is in hardware form as well as software. Okay. So what it is going to do, it is going to monitor your network traffic, incoming and outgoing, based on security rules. So if you have configured good rule, so any malicious traffic will not be able to enter in your system. Now, how firewall work? So firewall inspect the network traffic and the device whether it to allow or block based on preset rules such as IP address, ports, protocol. Okay. So how this thing going to work? Suppose that you have a web stream, you have a video streaming platform. Okay. So there, what kind of traffic you will see? You will see of TCP. Okay, UDP. Basically, if you have live streaming, then you are going to UDP. But if you will find that a packet containing FTP traffic is in your server, okay, and it is requesting for a video, it means someone wants to download because FTP enables the download in functionality. So by the rules, you can block that traffic. Okay. So we have multiple types of firewall. I introduced 4 only, but it is not limited. We have multiple types of firewall. But broadly, we are classifying this on 4 types: the packet filtering, stateful, proxy, and next generation firewall. So the packet filtering firewall work as the the network layer. It is going to be inspect the packet and block or allow based on IP address, port number, and protocol. Then in stateful inspection, it tracks the state of active connection and make decision based on the context of traffic. Okay, so it basically see the specific connection. Okay, in packet filtering, we are only seeing the packet. In stateful, we are going for specific connection which is established to our servers. Then we have proxy firewall. It also works at application layer, act as an intermediary between users and internet, filtering traffic based on application level data. Okay. Then we have next generation firewall. Especially for next generation firewall, no any formal definition is there. Okay. Whenever we are introducing a new technology or we are combining the traditional firewall with some new features, so we can say that this is a next generation firewall. For example, nowadays we have firewall with AI integrated firewall. So that will come to next generation firewall. And in industry, we are mainly using this one only. Okay. And then this is going to your first line of defense for network, and it will prevent from unauthorized access, attack, and malware. Then we have VPNs. VPN stand for virtual private network. Okay. So it is a proxy server, acts as an intermediary between the client and the internet, handling request and response on behalf of client. Okay. So basically, what is the working of the principle of VPN? So when a client sends a request to the server, so the proxy will intercept this. Okay, and forward the request to the server. Then the return will be returns the server response to the client. Okay, so what it is doing basically, suppose I want to communicate with Sachin. Okay, so but Gagan is VPN. So whenever I want to communicate with Sachin, my first line of communication will be Gagan. Then Gagan will forward the request to Sachin, and Sachin will respond to Gagan, and Gagan will forward to me. So there is no any direct connection. Okay. So we have different type like forward proxy, then reverse proxy, then transparent proxy, anonymous proxy, and high anonymity proxy or elite proxy. Okay, we have everything, all these things. Basically, we are using for security and anonymity purpose. And this is all about the basic of networking and network security. So any doubt in this slide?
So I have a
No, sir.
doubt for VPN.
Yes.
VPN is VPN. Basically, we use VPN, so we get the destination IP address logs.
Can you repeat the question?
If we use the VPN, then we visit any abusive website and so that after the VPN use, that destination IP and that IP address will stored with our request.
Okay, so on your side in VPN, on your side, it is going to be saved. Okay, because you are using the VPN, it means you are allowing your traffic to go on a specific location or a specific server. Okay, so you are hitting that server. But whenever the server is going to be respond, because look, I know that I need to communicate with Sachin. Okay, but my request is going through Gagan. In this case, I know Sachin, but Sachin don't know me. Okay, Sachin knows only.
So basically, server is do not get back that our IP address.
Yeah, server is not going to deal with your IP. Okay, server
Okay.
is going to deal with the VPN IP address. Okay, so that is the concept of virtual private network. Anyhow, you have the context, or you can say you have the info of the servers. Okay, any more doubt or discussion?
Sir, I have doubt related to project. Like in project, we have one project on which we have to do like vulnerability assessment on a machine, a virtual machine. So would that virtual machine would be provided by the like you, or we have to select any from the internet?
Okay, so for project we have a dedicated session. In that session only I will clear everything, that what kind of project we need to do in that project, what is your requirement, and accordingly to that I will guide you. Okay. For now, we are not providing any kind of virtual, or you can say that remote system. Okay.
Okay, sir.
Okay. Anyhow, you need to configure everything on your own machine. But what you need to configure, that I will explain in project session. Okay. The next is, I hope the next is in next session only I will explain the project and all. Okay, guys.
So when is our project session, sir?
Yes.
Our project session when conducted?
I hope that in the next session will be on project only. Okay.
Okay. And team members?
The admin team will give you the details of team member and all.
Okay. Thank you, sir.
Okay.